And so if the heavy particle collides a small particle, in order to conserve momentum, most of the kinetic energy must stay kinetic energy independently. If you have an elastic collision, as I show here, or an inelastic, and you produce new particles, then they take the kinetic energy. And if you have two particles with the same mass, if now I make a collision, you see that all the kinetic energy, I can do a little bit more heavy, but you see all kinetic energy is transferred to the new particle. Or if the particle would come together like that, they would exchange their kinetic energy and go away in an elastic collision, or they could produce new particles from all this kinetic energy.
Yeah. Because this is construction area, right? So everybody
All right.
with 4 experiments, so, which means there are 4 axes repeated particle physics.
Oh no, it looks safe.
Batterie! Batterie! Spent more than 10 years. So we hope the installation can be finished at the end of will be installed October. Right. Excavated from this underground cavern. So 50,000 ton concrete used to build this. There are a very special sequence to build this underground cavern. So first dig the vertical shaft. It's reach to the top of the surface. And then dig about 10 meters underground cavern. Because at that time there's no side wall, cannot build side wall. Burial area plus end cap. So this is one end cap area. Right? So this is we call central area, burial area. Then other side there are another end cap to detect the molecules.
So we're walking by the big magnets. There's like 40 meters or 70 meters of magnets. Wow! Looks huge.
So our big component come from here.
No, this is the Cern.
Yeah, because there are people mounted something here, so not allowed.
Okay.
This is
Sorry.
the limit. It's okay. Don't worry. This is the magnet. We have 8 toroidal magnet, 26 meters long. The coil inside like the racetrack, and the produced magnetic field is a circle, perpendicular to the beam direction. To bend high energy muon, we want to have a 4 Tesla magnetic field. To produce such high magnetic field, a lot of current needed. About 20,000 ampere current needed in the coil to produce a 4 Tesla magnetic field. So if we use a regular material, then the size will be like this. It's not possible to manufacture. So we have to use a superconductor. The inside the coil made by a niobium titanium. When this coil, this material cooling down to the 4.5 Kelvin, about 260 minus 269 degrees, there is no resistance in this coil. So when 20,000 ampere current passes through, will not produce heat. But we have to cooling it. So in Atlas detector, there are about 1,300 tons cold mass needed to be cooling down. Yeah. So it will take several weeks before we can switch our magnetic field.
So you're cooling down to the absolute minimum.
Not this is liquid helium temperature. Minus no, it's a 4.5 Kelvin, not absolute zero. Yes,
okay.
Very close.
Very close.
Yes, absolute zero is minus 273. So this is minus 269.
Coming into a superconducting state.
Yes, yes, yes. Because at that temperature is almost a superconductor. There is no resistance. Yeah. For LHC magnetic dipole, temperature even low, about 1.8 Kelvin. What you see just a vacuum isolate vessel, because the coil, need to be cooling down such a low temperature, so must isolate to the beam line. Detector parallel to the beam line. Detector located like a disc face to the beam line. So when particle make collision, then fry make collision, then particle will go. So and a couple area always like a disc. So you see, just face to the coming particle.
So when this is done, will this side look the same as the other side?
Yes.
Okay.
Symmetry.
Yeah. Okay.
So this is the two layer of the muon detector here. Yeah.
Is this the biggest experiment of LHC?
Yes.
Yeah.
This is the biggest. Yeah. In LHC there are 4 experiments, but only 2 experiments we call general purpose particle. One is Atlas, one is CMS. CMS is a little bit smaller than Atlas.
Alright. So this one is part of what cost was how much it was?
The cost for Atlas detector about 550 million Swiss francs. Yeah. It's all cost, most of them used for hardware, not include manpower, salary of manpower, because the manpower normally paid by institute, individual institute for university. The total cost for LHC is about 3 billion euros. The turner is old, not new. But this, for Atlas, the underground cavity is completely new, because the previous underground cavity is not big enough to hold the Atlas detector. But the magnet or device for LHC is completely new, because the magnet used for left is not good enough to use. Dismount everything and put the new magnet, because beam energy is completely different.
So there's another cavern for the old one? It was somewhere else?
Yes, there are several. There are 2 experiments reuse the underground cavern, which used for previous experiment, just to reduce the cost. Because the other 2 experiments is quite small, so it can be, put the new experiment. argon will become 700 liter gas argon. So the volume increased a lot. So this kind of gas will occupy the underground cavern. In this case, the oxygen level will be reduced. So this is why we mount a lot of oxygen sensor in this area. If oxygen level below 18%, normally the 21%, below 18%, then the light will start to flash and the siren will start. You will see alive sound in this area. So in this case, it should go on immediately. Yeah.
Has it happened before?
No.
No?
Not yet. Yeah. If oxygen level below 15%, it's very dangerous. So people will get asphyxiation. This is a sign of asphyxiation. Yeah. You.
So entering another area.
This area. Inside for experiment for detector. When we got in, we were completely closed. But this area is okay. People still can stay here, check the status, and we have some control. Trying to get data from transport here. It's now my electronic system. So Atlas. Well, it's small, about 12 meters diameter, big, about 18 meters diameter. I think both sides, look at both ends.
You said there's a lot of redundancy.
Yes.
But I mean, can you project out how many decades it will be before the whole thing will have to be?
Oh, yeah.
I'm sure they do a lot of
Yeah, because of radiation.
Yeah.
For example, for a silicon pixel detector, we tested by radiation. So we just try to keep the light on for 10 years. If the detector works at room temperature, it cannot withstand. So we have to cool this to the minus 10 degrees. Try to keep light on for 10 years. Because the detector problem one is because maybe after 10 years people already start to upgrade. We're making new. The magnetic field is a big volume. We want to have very good uniformity. So one layer coil is not enough. You see, we have 4 layers. A lot. Each layer about 20 coil to produce 4 Tesla and very uniformity magnetic field for muon detector.